Welcome to Introduction to Maya series. I am your instructor Rohan Page. In this video, we will learn the indirect lighting in Maya with the help of Global Illumination. What will be our workflow? First, we will see what is Global Illumination. We will understand the concept of Global Illumination. Then we will see what is the workflow of creating Global Illumination in Maya. Let's start with the session. Global illumination is indirect illumination, bounced or transmitted by nearby objects. This is a process of creating indirect light with the help of light bounce and color bleeding. As you can see in this image, uh, arrow which is displayed in a red color. Basically, if you'll observe this image, there is only one light source in this image, that is the sunlight which is coming through the top of this hallway, and it is as you can see that light rays may be falling on the floor, which is having a color, and when it will bounce, it is creating the color bleed. When it is bouncing, it is getting that color and reflecting it on the nearby object. As you can see over here also, at this area also you can see there is a secondary light, yellow color, little bit yellow tint is there, which is nothing but created because of the secondary bounce. Okay, so what is actual process? If you want to mimic this in Maya, how we can create it? Over this area also you can see there is a secondary light which is displayed in yellow color. So to perform this, what actually happens? Okay, so basically this is a primary light source which you will be creating. This light source will start emitting some points which I am over here creating. So there will be multiple points this light will be emitting within a scene, right? And these points are called as photons. Okay, so these photons are responsible to generate this color bleeding or the bounce of the color, which will be used as an indirect light, which will help to illuminate the area where light is not reaching. Okay, so it is kind of a secondary light. So let us see how we can create this global illumination in Maya. Let us see what is the workflow of creating global illumination in Maya. So first of all, I'll just create a basic scene over here. I'll just create a polygon plane, increase its width and height subdivisions. This is okay for me. Now I'll just create one cube, polycube, delete this face. I'll create one polysphere over here. I'll just place it this area, and I'll duplicate it, and I'll place one over here. Okay, now I'll give material to separate faces. I want different colors. I'll just select this face, assign new material, and I'll apply Lambert. Go to its material attribute and change the color to red. Select it, assign new material, Lambert, change its color to green. Select this one, assign new material, again Lambert. I'll change the color to blue. select this, assign new material, Lambert, change the color. Okay, so I have placed two spheres without any color. I don't want any color to be seen on this spheres. I have just assigned separate material to all the faces of the cube, and now I want to create a light source. So but before that, what you need to do is go to render setup, choose mental ray, because we can create global illumination with the help of mental ray renderer. You can create photorealistic effect with the help of this mental ray renderer. Now the first thing is you need to do is, as you can see, whenever though there is no light in my scene, if I'll take a render, I'll still will be able to see my objects. So first thing you need to do is go to common tab and render option, turn off this default light. Now let us create light source. So for that I'll go to create lights. I want to create spotlight as my key light, which will emit my photons. Keep the light selected. My light is selected. Go to panel, look through selected, press 7 on your keyboard to see the illumination area. Just place it according to your requirement. Go to its attribute editor and just increase the cone angle, which will cover whole scene. Okay, now I'll just go to perspective, place your camera. For example, I am in perspective only. I would like to render in this particular view. So you can bookmark this view. To do so, you just need to select the camera, go to view. There is an option called as bookmark in panel view. Click on edit bookmark and just click this new bookmark and close it. So you will get the name of the bookmark as a camera view, or if you want to change, you can change it from here only. So I'll just close it, and so you can move your camera, and if you want to go back to your saved camera angle, just go to view, bookmark, camera view. So you will go back to your view in which you want to render. Okay, so right now I have created a light. I just want to select it, select the light, make sure the shadows, ray trace shadows are on. Whenever you are using mental ray, you will also have to use only ray trace shadows. So turn on ray trace shadows, take a render. Okay, now shadows are on. I'm able to see the shadows. As you can see, there is no indirect light or no kind of a color bounce or secondary light getting illuminated. I have only one light in the scene, and the objects which are getting exposed directly to the light, the illumination is getting created over there. As you can see over here, this area is getting in front of directly of light, so it is illuminated due to the shadow area of the upper and this area of this plane. Only this area is illuminated, but other area is in shadow. I'm not able to see even what is there inside, and I have a shadow at this area and the basic illumination on the plane. Now how to create secondary illumination, how I can uh, create a light bounce so that I'll be able to see the innermost area also with the help of secondary light. So let us see how we can do that. First, save the image so that you can compare the results. Click over this particular image. Now close it. So to create global illumination, you will require to turn on the process of global illumination. Go to render setup. There, make sure that you are rendering using mental ray. Click on this indirect lighting tab. You will have a rollout global illumination. You just need to turn on that global illumination. First, I'll just make the accuracy value to 100. Let us see how it works with the default values. I'm not changing any of the further value. We will explain it in just when we will start with the test renders. So I have turned on the global illumination. Let us see, is there any kind of a change happening? So there is no such kind of color bounce or anything, though I have turned on the global illumination. But to make it work, light should emit photons. Whatever the light source available in your scene, it should emit photons. Then only the global illumination process will start creating the color bleeding and the indirect light. So to do so, you need to select the spotlight, go to attribute editor. Every light attribute have one rollout called as mental ray. Click on this mental ray rollout. There you will have an option of caustic and global illumination. Now I want to create global illumination. Turn on emit photon. So by enabling this option, your light will start emitting photons in scene. So the intensity of photon is 8000, whereas exponent is 2, and the global number of global helium photons which are getting generated is 10,000. Now talking about the intensity. The intensity of photon depends upon the distance between light and object. So light source, if the light source is close to the object, then you need to work with the photon intensity. You might require to reduce it. If the light distance is far away from the object, then you might need to increase the photon intensity according to the requirement. We will see this when while we will do the test renders. And the exponent is nothing but the energy of the photon, or the decay of the photon, you can say. If you will decrease the value, photon energy will stay for long in the scene, and it will create a greater impact or greater color bounce. If you will increase the exponent, then photon will lose their energy quickly. Number of global illumination photons, it is used to create greater what you can say very finished look. If you want, then you need to increase more number of global illumination photons. So let us see with the default value how it creates what kind of effect we get. So just go to bookmark, camera view. I am in camera view, I guess. Now just take a render. Now it will start taking some time. Okay, now over here you can see that there is a little bit of illumination over here. I am able to see this area of the back polygon face. I am able to see this also. Let us compare, right? So there is a little bit of indirect light which is created over here. Now you need to tweak the values. Let me just show you first what is the meaning of the attributes which we have for the global illumination. Then we will get the refined look. First of all, accuracy is not it is 100, so we will not get any kind of a good refined look. Second thing is number of global helium photon. Let us see how it is, how it looks, how photon looks. So to see that, right now go to render setup, and there is an option called as radius. If the value of the radius is 0, then computer is automatically calculating its own radius. It will take its own radius for the photon, and you will get the generated effect. But if you will mention it, suppose I want to see the global helium photon radius like 0.1. Now take a render. Now the radius of the photon is very low, so I am able to see each and every photon over here. So you can see the photons somewhere distributed, with a very large amount of photons are available, whereas some areas there are no photons. So when light is emitting photons, it will distribute it accordingly, means like randomly. Some area will have large number of photons, but some area will have less number of photons. So the area where there are a lot of photons, you will get the more light, and the area where there is less number of photons, you will get less amount of indirect light. So you can see there are red color photon, there are which are getting reflected at the top, also green color and blue color also over here. So basically this is the color bounce which is happening due to photons. Now we need to refine everything. So if you want to distribute all the photons equally, if you want to distribute all the photons equally, then what you can do? So I'll just save this image so that you can compare the distribution of the photons. I'll just increase the merge distance. So when it is 0, then all the photons are not equally divided or at a equal distance, equally spaced. I'll just give this value 0.5. So as soon as merge distance value is used, it is used to decide or give a spacing between the photons. Now you can see these photons are equally distributed within scene. See over here, and this is the difference. So increasing the value is going to distribute the photons at that distance. I don't want such kind of large distance, 0.5. I just used it to show how it looks. So now I'll have to work on a final render setting. So for example, I'll have to use merge distance 0.1, and I would like to use the radius because I want to merge all the photons with each other and create a refined look. I'll give a maximum radius like 3 or 4. We'll increase the accuracy later on. Let us see. Let us also work on number of photons and the intensity. So first of all, increase the global illumination photons. Let us increase it to 1 lakh. Increase the photon intensity around 25,000. Take a render. Okay, pretty good than the earlier one. You can now see all the inner part of the cube. You can see there is a red color getting reflected at the top. You can see there is a blue color which is reflected at the floor. Now to increase it or to have more effect, so how we can work with it? Now suppose rather than increasing the photon intensity, I'll not suggest you to work with exponent, because exponent value 2 is quite photorealistic, and it gives a photorealistic effect for the photon energy. But let us for the experiment purpose, I'll just reduce it to 1.5. Now you can see the overall global illumination is than the earlier one. Let me just delete these image. Now you can see that from previous one, this was also a global illumination, but the effect was very low. Energy of the photon was not that good. But at this area, I just reduced the exponent value, which means the energy of photon is remaining for the long time within the scene, and it's creating the greater impact of the secondary light, or it is creating a greater amount of secondary light. The color bounce, color bleed, you can see over here is too much, right? So it's also depend on the exponent value. If I'm increasing like 2.5, the photon will lose energy early, and the effect will be the effect will not get that kind of effect again. I'm having very less amount of secondary light. So working with exponent can be good or bad. It's up to you. Generally we don't change the value of exponent. So rather than that, you can play with the value of photon intensity. I'll keep it to around 80,000. Right. Again, I have got the pretty much same amount of indirect light with the help of photon intensity. The exponent is 2. So you can play with the values, and you can get the the indirect light getting bounced with the amount you want. Now, to I don't want to have such kind of a blotchy effect, so for that what you can do is just increase the accuracy value to 500 or 1000. It's up to you. Can increase the radius to 5. If you want to, you can increase the number of uh, global illumination photons around 1,75,000. Take a render. So as you can see, I'm having a better and not so blotchy effect. See, the previous we were not having any kind of a good amount of secondary light. It was there but not that good, and also the effect was the blotchy one. It was not so fine tuned. Over here you can see I am having very refined look of the global illumination. I am able to see the shadow area also, but I am also able to see the inner area. So you can see overall if color reflected at the top, overall color reflected inside with the blue color, and also on object we have red color getting bounced. So this is how you can create a global illumination in a scene. This is a basic concept. We can explore it further in interior and exterior also. So let us see what we have learned in this video. What we learned in this video: we have seen that global illumination is indirect illumination, bounced or transmitted by nearby objects. In this process, indirect light is generated through light and color bleeding. For any query, you can follow me on Facebook. You can write me an email on rohan.pageanimator@gmail.com. You can subscribe to my YouTube channel, or else you can join the classroom by using this code 4H47DWO. Thank you.